recording. All right. So let's go back a little bit. So everyone should by now know how to factor an equation like this. So we've worked extensively with equations that look something like you should know how to solve it, you should know how to factor it, etc. Okay? Am I right? Hopefully.
Yeah.
Right? We should know basically everything about this equation, how to solve it, how to factor it, yada, yada, yada. Now, let's talk about an equation like this. What is that? Can anyone tell me? I'm waiting for somebody to chime in.
That is x squared minus 264.
Yeah, I know it's x squared minus 64, but what type of special case is this?
What type of special case is this?
How do we factor something like this?
Don't you like like a 0x or something?
Remember something like this? I'm going to mute everybody. So when you have to say something, just unmute yourself.
Okay.
Okay. So remember, this was a difference of squares, and we know it was a difference of square because we have a perfect square minus a perfect square. Okay, and when you do that, you get two conjugates, square root of the first minus the square root of the second times square root of the first plus the square root of the second. Okay. Now, that is one type of special case. So when we talk about factoring, we talked about two special cases. And the first one was a difference of squares. The second, and this was the example I gave you. And it's basically the binomial multiplied by its conjugate. Okay. The other one that is a special case is known as a perfect square trinomial. And it is a equation like this: x squared minus 8x plus 16. Now, when we factor this, we do basically the same thing. Okay, the first terms are x, and the last term, we're looking for factors of 16 that add to give me -8. So, for example, the factors of 16 are 116, -1, -16, 2, 8, the negative versions of that, and -4, 4. -4, -4, and 4, 4. Sorry. So all of these are factors of 16, okay? Positive and negative factors of 16. And when we add them, we get 1 plus 16, which is 17, -17, 10, -10, -8, and 8. And of course, since we're looking for something that multiplies to give me 16 but adds to give me -8, the one that we have to use is this guy right here, -4, -4. So this is x minus 4 times x minus 4. Well, remember, when you have a number multiplied by itself, we can rewrite this using an exponent. That's a times a is basically a squared. But notice we have x minus 4 times x minus 4, so multiplied by itself. So you can rewrite this as x minus 4 squared. And that's why this is known as a perfect squared trinomial, because when you factor this, you get a binomial, in this case x minus 4 squared. Now, can you factor this using the old methods of factoring like we did right here? Yes, you can. But sometimes you want to be able to look at a trinomial and see if it's a perfect square. And the formula for a perfect square trinomial is this. Okay. So I'll give you another example. Now, I know it's a perfect square trinomial because this is p squared, and the last term is 5 squared. So the first term is a perfect square, the last term is a perfect square, and the middle term is either positive or negative, and it's 2 times the square root of the first term, which is p, times the square root of the last term. Okay. And if we have a situation like this, when you have a perfect square trinomial, you can factor it as the square root of the first plus or minus, depending on what sign this is, the square root of the last squared. You don't have to do all of this stuff that we just did here for that. So the purpose of this is you need to start looking at your trinomials and being able to tell when you're dealing with a regular trinomial, when you're dealing with a difference of squares, and when you're dealing with a perfect square trinomial. Okay.
So why ain't P in the problem? Like in the middle part of it?
What do you mean?
Like P ain't, like the variable P ain't in the
Oh yeah, I'm sorry.
10x.
Yeah, sorry. There we go. My bad. Okay. Now let's list my perfect square trinomials. Okay. So x squared plus or minus 2x plus 1, x squared plus or minus 4x plus 4, x squared plus or minus 6x plus 9, x squared plus or minus 8x plus 16, x squared plus or minus 10x plus 25, x squared plus or minus 12x plus 36, and so these are some perfect square trinomials. Obviously, there's an infinite number of perfect squares, but these are some of them. Okay. And when you factor this, you get x plus or minus 1 squared, x plus or minus 2 squared, x plus or minus 3 squared, and so on. Okay. So the key is not to memorize these, but to look at the same pattern that all of these trinomials have. Okay. And all of them have the same characteristic. It's the first term squared, last term is a perfect square, and the middle term is basically the square root of the first term, which in this case is x, times the square root of 1, which is 1, times 2. Okay. So for example here, the middle term is the square root of the first term, which is x, times the square root of 9, which is 3, times 2. That's how I get 6. Here, square root of the first term, square root of the second term, which is 5, times 2, which is 10. Square root of the first term, square root of the second term, which is 6, times 2, which is 12. Okay. Does everyone see the pattern?
Yes.
Okay, and it is important for you to look at these patterns and recognize them, because eventually we're going to be doing something called completing the square. And if you do not know what a perfect square trinomial is, you will not be able to complete the square. Okay. Again, I'm not asking you to memorize it. I'm asking you to look for a pattern. Okay. So when you encounter different quadratics, you should be able to tell me what type of quadratic you're dealing with. Well, this is a difference of squares. This is just a regular quadratic that you're going to factor the normal way. And this is a perfect square trinomial. Okay. And the reason I know this is a difference of squares is because it's the difference, that means the subtraction of a perfect square minus another perfect square. I know this is a perfect square trinomial because it's the middle term, I get it from the square root of the first term times 2 times the square root of the last term, which is 9 times 2, which is 18. Okay. Everyone on the same page?
Yes.
Okay. So let's talk about quadratics. So remember when we were talking about classifying polynomials, I said quadratic is a degree 2 polynomial. So any polynomial whose largest exponent is 2 is known as a quadratic. Okay. And we know everything about these types of equations. Everything. We know how to solve these equations, whether they're factorable or not. We know how the shape of it is, and etc. All right. So the question is, why would anyone in their right mind study one equation type in detail? Well, think about it. If you take any object, no, I can't find an object here. If you take any object and you throw it up in the air with your right hand and catch it with your left hand, which I can't catch, the path that it takes in the air is this path right here. So let's say this is I know I can't draw, so don't laugh. Okay. It makes this path right here. Okay. And this is known as a parabola. Okay. Parabola. And the graph of any quadratic is a parabola. So if we know everything about quadratics, we can shoot a missile in the air and have it land at a specific spot. These are how your intercontinental ballistic missiles work. Okay. You know how high it is, how high it will get, you know when it will reach that height, etc. You'll know how far it will get. And these are things that we do to this day. So think about North Korea. If North Korea ever launches a missile at us, right? If we want to deflect that missile, we need to know the trajectory of that missile launched by North Korea so that we can hit that missile with our own missile at the right point. Well, look at the path the missile takes. If you're on planet Earth, it's going to shoot from North Korea and then it's going to come down this way. Well, this is a parabola. And same thing with ours. When we shoot a missile, it's going to go up and it's going to come back down. So that's a parabola. So this is why we study quadratics, because the graph of a quadratic is a parabola.
Why you bring up North Korea?
Well, that's just something on top of my head. Okay. All right. And anything that you do, anything that you throw, like if you throw a football, if you throw a baseball, if you throw a softball, everything has that same arc, okay? So if you throw a football, okay, it goes up in the air, it'll go to a certain point, then it'll start going down again, okay? Unless you're Dorian, in which case the ball just goes like this.
Hold on now.
Hold
Hold on. Run it back, man. What you just said? So you
All
trying
right,
to
I
make
just,
fun
was
of me.
I just
Go,
wanted
man.
to see if you're paying attention, that's all.
Yeah, I am, man.
Whole squad.
Talking about me.
Nine.
I throw that heat in every sport.
All right. Okay.
That
Dorian has a daughter on the
can't
way.
kick.
Anyway, go ahead.
Let's talk about this. So let's talk about the general form of a quadratic equation. Okay. That's the general form of a quadratic equation. And it should look familiar because think about it. You factored stuff like this. So all of the equations that you've been dealing with in this chapter have been looking like this, okay? And something to know, A, B, and C are numbers, okay? And X is your variable, okay? So quadratic equation is any equation of degree 2. That means the largest exponent in that equation is 2. The shape of a quadratic equation is a parabola. And the standard form or general form is given by this equation. It is known as the standard form. Okay, and A, B, C are numbers. Now, what is the name that we give to a number in front of a variable?
Coefficient.
Coefficient, right. So A, B, and C are not just numbers, but they're actually called coefficients, because they're numbers in front of variables. So A, since it is in front of the variable with the largest exponent, A is known as the leading coefficient, because it is the coefficient in front of the x squared term. B is known as the linear coefficient, because it is in front of the variable exponent 1. And C is known as your constant term. Okay. Now, if you look at this parabola right here, okay, it goes up, then it gets to a point and it starts going down again, okay? It goes up, gets to a point and starts going down again. When I'm mapping the ocean floor, okay, I send out a radio signal, it hits a rock, and it goes back up again. So again, this is a parabola. This curve is known as a parabola. And notice, it keeps going down and then it stops and goes back up again. Where that graph changes from going down to going up or from going up to going down is known as the vertex of the parabola. So here's a parabola on a graph where it transitions from where it changes from going down to starting to go up is known as the vertex. It's a point on the parabola, okay? Now, we can find this vertex in an equation. So if this is your general equation, the vertex, we have a formula to find the vertex, okay? So the vertex is a point, so it has an x coordinate and a y coordinate, okay? The x coordinate is labeled h and the y coordinate is labeled k. Okay. To find the x coordinate, you take the linear coefficient, put a negative in front of it, and divide it by 2 times the leading coefficient. Okay, and that gets you the x coordinate, or h, of the vertex. Okay. So let's take a quadratic. Okay. And I want to find the x coordinate of this quadratic, the x coordinate of the vertex of this quadratic. So the first thing I do is write out what are my a, b, and c terms: leading coefficient, linear coefficient, and constant term. And by doing this, I don't have to worry about the equation anymore. Okay. So to find the x coordinate h, it's negative b, so negative of negative 12 over 2 times a, which is 2. So when we take the negative of negative 12, it becomes positive over 2 times 2, which is 4, which reduces to 3. So the x coordinate of the vertex is 3. Okay. So far, so good? Anyone have any questions so far?
No.
All right.
No, sir.
Okay, now to find the y coordinate of the vertex, because remember it's a point, it has an x coordinate and a y coordinate. So to find the y coordinate, whatever I found h to be, so in this case, h is 3. In order to find the y coordinate, I plug it back in, okay? I plug the x back into the equation. So in this case, we found h, or the x coordinate, to be 3. So I plug 3 back into the original equation for x and solve. So remember your order of operation. This is an order of operations problem. The first thing we do is exponents, and then we do multiplication from left to right. Then we do multiplication or division, whatever occurs from left to right. Then we do addition or subtraction. So this is 2 times 9.
Mr. D,
Yes.
if I finish your course, do I have to come to these Zoom meetings?
No.
Okay.
Okay. So the y coordinate, also known as k, is negative 11. So the vertex of this parabola is 3, negative 11. This is known as h. This is known as k. So far, so good? Now,
Yes.
another characteristic of a parabola.
Yes, sir.
Okay, the parabola is symmetrical. That means half of it can be folded on top of the other half. And the line that it is symmetrical on, the line that you can fold half of the parabola on so that it lands on the other half, is known as the axis of symmetry. Okay, axis of symmetry. And to find the axis of symmetry, it's a vertical line. So remember, vertical lines have the formula x equals some number, okay? So the axis of symmetry has the equation x equals whatever the x coordinate of the vertex is. So the axis of symmetry is a vertical line going through the vertex along which you can fold the parabola so one half of it lands on top of the other. Now the axis of symmetry, everything is equal distance from the axis. So say for example, I have this point right here. If it's 3 units away to the right from the axis of symmetry, the same point on the opposite side would be 3 units to the left. Okay. I'm just making an example if it was 3 units. Okay. So if this was, say, 10 units to the left, there's a point that is exactly 10 units to the right. Okay. So, recap. To find the x coordinate, it's negative b over 2a. Okay, once you find the x coordinate of the vertex, plug the x into the equation, find the y coordinate. Okay, so now that you know the x coordinate and y coordinate, that is your vertex point. Okay, your axis of symmetry is a vertical line that goes to the vertex. So it's x equals the x coordinate of the vertex, h. All right, let's do an example. Okay. So find the vertex, find the axis of symmetry. So everyone should be doing this example. Anyone got an answer yet? Well,
No, sir.
y'all know how to start, or are y'all totally lost?
I kind of do.
So step one, write A, B, and C. The first thing y'all want to do is just identify A, B, and C. Identify the leading coefficient, the linear coefficient, and the constant term. What is a leading coefficient? A. This equation, what's my leading coefficient?
Negative, or no, 3, my bad.
3. What's my linear coefficient?
24.
Constant term?
Negative.
Okay. So that's the first thing you want to do. Okay. Now, to find the vertex, the x coordinate is known as h, the y coordinate is known as k. So h, the formula is negative b divided by 2a. So negative b, so negative 24 divided by 2 times a, which is 3. That's negative 24 divided by 6 gives me negative 4. So the x coordinate is negative 4. Find the y coordinate, you plug negative 4 back in for x. Okay. So remember, you do your exponents first. Then you multiply across.
That's good right there. Mars, that's my home. Gang,
Then
gang.
you solve. So the y coordinate is negative 49. So my vertex is negative 4, negative 49. Okay. And the the axis of symmetry is just x equals the x coordinate. Okay. So let me highlight these. That's my vertex. That's my axis of symmetry. Now, y-intercept. Okay, the y-intercept. Remember, the y-intercept is where the graph crosses the y-axis. The y-intercept is 0, comma, the constant term. So the y-intercept in this equation is 0, negative 1. Okay. So looking at a formula, you should be able to tell me the x-intercept, the vertex, the axis of symmetry, and the y-intercept. Okay. Now, when you have a parabola, you can have one of two situations. Okay. You can have the thing opening up. Okay. Or you can have the thing opening down. So it can either be happy or sad. Okay. And which way it opens depends upon the sign of the leading coefficient. If A is positive, it opens up. Okay. And if A is negative, it opens down. So now with all this information, you can draw the parabola. If you're given an equation, you can determine the vertex. So the point where things transition. You could look at the sign of the leading coefficient to see which way it opens, and you see also where it crosses the y-axis. Now, in order to find the x-intercepts, this is where factoring comes into play. So you set the y equal to 0 and factor and solve. So when you factor and you find the values of x, those are the values where it crosses the x-axis. All right. So let's do an entire problem. Let's look at y equals, say, x squared minus 6x plus 9. All right. Okay, let's do another one. Let's not do plus 9. Let's do So vertex. First, identify your leading coefficient, your linear coefficient, and your constant term. So to find the x-coordinate, it's negative b, so negative of -6, divided by 2 times a, which in this case is 1. So we get 6 divided by 2, which is 3. So the x-coordinate of my vertex is 3. Okay. Find the y-coordinate, you plug that x back into the original equation. So 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8. That's -9 plus 8, which is -1. So the y-coordinate is -1. So the vertex is 3, -1. Okay, the next thing, axis of symmetry. Axis of symmetry is basically, remember, a vertical line, x equals the x-coordinate of the vertex, which in this case, the x-coordinate is 3. So, there you go. Okay, next thing, y-intercept, where it crosses the y-axis, is basically 0, comma, the leading, the constant term. So the constant term in this equation is 8. So the y-intercept is 0, 8. Now, remember, it can either open up or down. And because x, the coefficient is positive, it opens up. Okay. Now, the last thing is finding the x-intercepts. So we're going to solve this equation to find the x-intercepts. So we have to factor. So two numbers that multiply to give me -6, but add to give, and multiply to give me +8, but add to give me -6. -2 and -4. Then we solve each one. So the x-intercepts are 2 and 4. And that's where it crosses the x-axis. Okay. So now, knowing all of that, we can graph it. Okay. So it crosses at 3, -1. Okay. It crosses the x-axis at 2 and at 4. Crosses the y-axis at 8. And it is symmetrical along x equals 3. And if you didn't have a horrible drawing skill, you can draw it. There you go. All right. So these are the main characteristics of a parabola: the vertex, axis of symmetry, y-intercept, x-intercept, and which way it opens. All right. Any questions?
No, sir.
All right. So if there's no more questions, then we'll stop here for today, and then we'll pick up tomorrow, and we'll talk about quadratics that can't be factored. Because up to now, all of the quadratics you've been dealing with are factorable quadratics. So we're going to talk about, well, first of all, talk about the vertex form of an equation and non-factorable quadratics.
Mr.
Right.
D, I've got a question about the radical things, like
Okay.
one of them.
Okay, go ahead.
So one of the problems was, it had like the cube root of x squared times the fourth root of x cubed. Wouldn't you make those both fractions and then multiply them?
Mm-hmm. So the
Yeah,
fourth root of x cubed, like that?
Yeah,
So
I did
remember-
that. I turned it into a fraction, multiplied it, and then it said I got it wrong. I guess I'm missing a step. I don't know.
So when we multiply, what do we do with my exponents?
You combine them.
You add them, right? So when you add them, what do you get? You get, so you have to find a common denominator, which is what, 12? So this is 8,
Yes.
12 plus 9 12s, which is 17 12s. Okay. And so if you convert this, it'd be 1 and 5 12ths, which is x times 12. Is that what you got?
No, I just multiplied the exponents.
So they probably want you to write it in radical form,
Yeah,
right?
I just multiplied it. Like I didn't add the exponents. I multiplied them.
Okay, well that's probably where you.
Because I put them. I just dropped the x and like moved it to the side and made it to fractions. That's what messed me up.
Yeah, you're supposed to make it into fractions, but then you're supposed to multiply. I mean, when you multiply exponents, you're actually adding them. Okay.
Yeah.
Okay.
Okay. Thank you.
Any more questions?
No, sir.
All right. If there's no more questions, then I will see you guys
sir.
tomorrow. All right.
All right, Mr. D.
All right.
Yeah,
I'll
Have a
probably
good
be
night.
done with
You
your whole
too.
course by tomorrow.
Hey, Mr. D, about the
Yeah.
attendance, you said we only got to attend 2?
Yeah, 2 a week.
Okay.
Yeah.
All right.
Have a nice day, guys.
You too.
Mhm.
Bye.